The assessment being discussed in this video is the YMCA submaximal cycle ergometer test. Completed by Bellarmine Exercise Science students Dalton Berry, Devin Clark, Emma Stairs, and Joseph Daniel. The YMCA submaximal cycle test is used to estimate the aerobic capacity, or VO2 max, of an individual. This type of graded exercise test is completed using a cycle ergometer and allows aerobic capacity to be estimated without reaching maximal heart rate. Although submaximal testing is not as accurate as maximal testing, the YMCA submaximal cycle test is a fast and cost-effective way to estimate the aerobic capacity of multiple people. Aerobic capacity indicates a person's level of cardiorespiratory fitness. It is important to know the aerobic capacity of an individual in order to prescribe an appropriate exercise regimen and monitor progression. Poor cardiorespiratory fitness is directly linked to cardiovascular disease and other diseases. Key terms for this assessment include steady state heart rate. This is when a participant's heart rate reaches a steady state for the current workload. This must be within plus or minus 6 beats per minute. Resistance. This is the measure of pure opposition to electrical current flowing through the body, a vector of impedance. RPM, revolutions per minute, the number of rotations that are being performed. Cycle ergometer, a stationary bike that can be increased in resistance at precise amounts. The distance of the wheel is constant at 6 meters. VO2 max, also known as aerobic capacity, is the maximum rate of oxygen utilization of muscles during exercise. The purpose of the YMCA submaximal exercise test is to estimate relative VO2 max for the purpose of assessing cardiorespiratory fitness. Necessary equipment needed to perform this test includes blood pressure cuff, stethoscope, cycle ergometer, and timer. The participant for this test is Dalton Berry. His age is 21, sex male, weight 169 pounds or 76.8 kilograms, resting heart rate 64 beats per minute, resting blood pressure 120/66 millimeters of mercury. The test administrators are Devin Clark to assess blood pressure, Emma Stairs to time, record data, and adjust resistance, Joseph Daniel to assess heart rate. First, a willing participant must be selected. We must record their age, gender, and weight. For this participant, Dalton, his age is 21, gender male, weight 169 pounds. We must then calculate his predicted heart rate max and 85% heart rate max. Heart rate max can be calculated by taking 220 and subtracting the participant's age. For Dalton, this would be 220 minus 21. This gives us 199. To calculate 85% of his heart rate max, we will take his heart rate max and multiply it by 0.85. For Dalton, this would be 199 multiplied by 0.85, giving us 169. Next, we must take the participant's resting heart rate. We can do this by placing the index and middle fingers over the radial artery for 15 seconds and multiplying the number of beats by 4. For Dalton, his resting heart rate would be 64 beats per minute. Then we must take the resting blood pressure. We can do this by wrapping the blood pressure cuff around the participant's upper arm and applying the stethoscope to the brachial artery. The first beat heard is the systolic value, and the last beat heard is the diastolic value. Dalton's blood pressure is 120/66 millimeters of mercury. Have the participant mount the cycle ergometer and adjust the seat so that there is a slight bend in the knee at the furthest point of rotation. Have the participant warm up by cycling for 3 minutes at 50 RPMs with 0 kilograms of resistance. After the 3 minutes is up, stage 1 begins when 0.5 kilograms is added to the flywheel and the timer is started. At 1 minute and 45 seconds, the first heart rate is taken. Dalton's heart rate is 90 beats per minute. At 2 minutes, blood pressure is taken. Dalton's blood pressure is 128/68. At 3 minutes, heart rate is taken. Dalton's heart rate is 104 beats per minute. At 4 minutes, heart rate is taken. Dalton's heart rate is 104 beats per minute. Since the heart rates are within plus or minus 6 beats per minute, Dalton has reached steady state and can move to stage 2. If the participant does not happen to reach steady state in minutes 2 and 3, then continue into minutes 4 and 5 until steady state is reached, as seen in stage 1. Next, refer to the protocol to determine the resistance for stage 2. The resistance is determined from the average steady state heart rate of the participant from stage 1. Dalton's average steady state heart rate for stage 1 was 104 beats per minute. For Dalton, the protocol indicates that 0.5 kilograms of resistance is to be added for stage 2, to make for a total of 1 kilogram of resistance. At 1 minute and 45 seconds, heart rate is taken. Dalton's heart rate is 108 beats per minute. At 2 minutes, blood pressure is taken. Dalton's blood pressure is 142/58. At 3 minutes, heart rate is taken. Dalton's heart rate is 112 beats per minute. At 4 minutes, heart rate is taken. Dalton's heart rate is 114 beats per minute. Since his heart rate reached a steady state within plus or minus 6 beats per minute, then Dalton can move to stage 3. The test is complete when the participant achieves a steady state heart rate above 110 beats per minute in 2 consecutive trials. Because Dalton has not done so yet, we must continue into stage 3. His average steady state heart rate for stage 2 was 113 beats per minute. For Dalton, the protocol indicates that 0.5 kilograms of resistance is to be added for stage 3, to make for a total of 1.5 kilograms of resistance. At 1 minute and 45 seconds, his heart rate is taken. Dalton's heart rate is 120 beats per minute. At 2 minutes, his blood pressure is taken. Dalton's blood pressure is 156/68. At 3 minutes, his heart rate is taken. Dalton's heart rate is 124 beats per minute. Because the heart rates are within plus or minus 6 beats per minute, Dalton has reached steady state. Because Dalton has reached a steady state heart rate above 110 beats per minute for 2 consecutive times, we do not move to stage 4. The participant is then instructed to cool down for 3 minutes. At 1 minute, heart rate is recorded. Dalton's heart rate is 100 beats per minute. At 2 minutes, heart rate is recorded. Dalton's heart rate is 96 beats per minute. At 3 minutes, heart rate and blood pressure are recorded. Dalton's heart rate is 92 beats per minute. His blood pressure is 136/60. Raw data collected can be seen on the sheet to the right. In order to obtain relative VO2 max, both a chart and calculation are needed. Steady state heart rates were averaged for plotting on the chart. Workload in kilogram force per minute was calculated by multiplying the kilogram workload by 300. Only stages in which steady state heart rates were between 110 and 150 beats per minute are plotted. In order to obtain the predicted absolute VO2 max from the results, we must first draw a horizontal line on the chart at the participant's age predicted heart rate max. Then we must mark the 2 points from the stages that achieved 110 beats per minute steady state. Use the average steady state heart rate from the stage and the workload. A line is then drawn through the 2 points in part 2. Next, the intersection of the max heart rate line and the test results line is marked, and a vertical line is drawn down from this intersection. The corresponding VO2 at the bottom is the predicted absolute VO2 max measured in liters per minute. In order to convert absolute VO2 max to relative VO2 max, we must multiply the absolute VO2 by 1000 to get the amount of oxygen in milliliters rather than in liters. Then, we divide by the participant's weight in kilograms to get milliliters per kilogram per minute. The results are interpreted using Table 4.8 from the ACSM's Guidelines for Exercise Testing and Prescription. Dalton's relative VO2 max was 49.48 milliliters per kilogram per minute. This is categorized as above average. This means that he is capable of withstanding a moderate to vigorous intensity of exercise and has good cardiorespiratory fitness. A common testing-related issue can be instrumental error. This can be avoided by practicing heart rate and blood pressure assessment skills prior to testing. Also, making sure that cycle ergometers are calibrated correctly will yield more accurate results. Some participants may not be accustomed to cycling against resistance and may experience muscular fatigue before true estimation of VO2 max is reached. We should encourage participants during testing to do their best. Moderate to vigorous cardiorespiratory activity at 60 to 80% of your VO2 reserve or heart rate reserve, 20 to 60 minutes, 3 times per week, can improve performance in this assessment and cardiorespiratory fitness. This concludes our presentation. Hopefully you have found this video useful in completing your YMCA submaximal cycle ergometer test. Thank you for watching, and if you have any further questions, there are some resources listed below.